Let's continue our study of relationships between classes by examining a program that tracks charity donations. Here's our problem statement. Most, if not all, charities accept cash donations. Some charities also collect goods for resale. Now, this is generally a good thing. It prevents usable goods from going into a landfill. Donors get credit for their taxes, and the charity gets money to do good deeds. We're going to implement a program that keeps track of the donations made by individuals to a charity. This will provide tax records of donations for donors and provide a revenue summary to the charity. We'll also provide a list of donated items to the charity. We're taking a big step forward here that you may not notice if I don't point it out to you, and that's that we're talking about a generic charity instead of talking about a specific one. This is a very important step forward in programming. There are many organizations that have similar needs. So if you program for a group of organizations instead of for a single organization, it makes it possible to sell your software to more people. This makes software more lucrative and often also makes the software better. Now, to do this successfully, you really need to have several different but similar organizations to talk to about their needs. The problem is that every organization has its own little peculiarities. And so if you create software for just one organization, it can be very hard to adapt it for a second organization. On the other hand, if you create software for 4 or 5 organizations, sometimes that process is a little bit easier. It also keeps the cost down for the organizations, and that can be good too. Let's think about what our test data should look like. We should probably have at least 4 donors. One should make only cash donations. One should donate items but no cash, so maybe 2 shirts, one valued at $2 and one valued at $4. One should have both donated items in cash, so maybe 2 pairs of pants, one for $3, one for $5, one for $7, and then $50 in cash. And then one without any donations this year. Incidentally, when you're writing this software, it's quite important to keep track of how you treat people who didn't make any donations this year but who've made donations in the past. You want to treat them very respectfully. These people are potential future donors, even if they didn't donate this year. So you don't want to be saying things like, hey, you deadbeat, where did you get off not giving me money this year? Because that pretty much guarantees they won't give you money next year. Now remember, your clients at the charity will help you with things like that, because these are all lessons that they will know. One thing that's very important when you're designing software is to respect the expertise of your clients. Trust them to know their business. Don't think you know their business better than they do, because you do not. Now, each charity should have, at the end, $150 in cash and $21 of donations with 5 items. So those will be the test data we'll use when we get around to testing this software. The next thing we need to do is to talk about the design. So there are lots of different ways to do design, and the way that I'm suggesting that I'm going to model here is the way that I've learned to do it over the years. Certainly there are people who do it differently than this and still are very successful designers. So this is just one way to do it, not necessarily the only way or the correct way. The first thing I do is pick the classes. Then I pick the data in the classes, and then I pick the relationships between the classes. After all that's done, then I pick the methods and the constructors. Now, the reason is this forces me to think about the big items, particularly the relationships, early in the design process. The later you get in the design process, the more ownership you're going to feel of the design, and the harder it's going to be for you to make changes to it. And so you want to make sure that the big items are handled first. Like I say, it's not the only way to design, but it is a way that's worked very well for me over the years. Now, there's lots of back and forth between steps. So while I've presented this as sort of a linear process, it is nothing but linear. And in fact, good design is very time-consuming and does take a lot of iterations. So don't expect it to be perfect the first time. The other thing that I do in design is I use UML extensively. This saves many, many, many hours of work because once you've implemented things, then you feel even more ownership of them. And when you feel ownership, sometimes that clouds your decisions that you're making during design. Now, it does take some practice to learn how to visualize the UML and to learn to understand what the UML means, but I strongly recommend that you participate in that process. So let's think about what some of our classes should be. Well, the classes are usually the nouns in the problem statement. Donor, donation, charity. So right there we have some of the classes that are going to be involved. Now we actually don't have all the classes that we'll eventually have, and that's fine. This is a great place to start. The next thing we need to think about is how the relationships are going to be between classes. There are two relationships we have at this time. One is called aggregation. The sort of nickname for aggregation is has or has-a. And so that's a good way to remember that when you can say A has a B, that probably means that A and B are related by an aggregation relationship. Now, in Java, how aggregation is implemented is a class with a data field from another class. So sometimes that will help you, particularly as you're starting to really understand aggregation, to recognize when you're seeing that. The UML symbol for aggregation is an open diamond and then a long line. The diamond goes to the aggregating class, that is the bigger class. The other relationship is called dependency, or uses. And so uses is kind of the nickname for that. Now in Java, this relationship exists when a class has a local variable or a parameter from another class, but not a data field. So you can see uses is a much weaker relationship. Now, one of the things about uses relationships is they often don't get documented in the UML unless they're very, very important. So a lot of these things tend to be sort of coincidental or minor. Remember with UML, you always have the option of how much detail you're going to display. You don't have to show every single element in order to know that the UML is good. So the strategy of how much to show and how much not to show is very much a part of the UML design. The UML symbol, by the way, for dependency is a dotted line with an arrow on the end, sort of a greater than sign, or less than sign, depending on which direction it's pointing in. Let's think about what our relationships between classes are now using the classes that we have. Well, a charity has donors. So that means the relationship between charity and donor is an aggregation relationship. A charity also has donations. So that means the relationship between charity and donations is also aggregation. Now the relationship between donor and donations, that one's a little bit more complicated. So this is what we have so far. The charity aggregates donor and donation. But we know that a donor has a donation, which would look like this, aggregating, and a donation has a donor, which looks like that. Now, I'm not saying that strategy is impossible, but notice we're getting a complicated relationship between those two classes. There's a lot happening there, so you really want to think about whether that's the right way to implement this software. These relationships are duplicative. One of the problems with duplicative relationships, where you have donor as part of a donation and donation as part of a donor, is keeping them updated when you make changes. It's very easy to change one and to forget to change the other. So this is a sign of a bad design. So let's think about which way this should really be. Let's think about what our original specifications were. We were asked things like finding the value of the donor's donation. So that means that the donor object needs to be able to access its donations directly. That suggests that the donor aggregating the donations is more important than the donations aggregating the donor. Now again, this is complicated stuff and there isn't necessarily one right answer, but to me that seems like the better relationship to keep. The other thing you might notice here is that even if we remove that second aggregation between donor and donation, the donation is still being aggregated by two classes. And you might wonder whether that's a good idea or not too. Well, it depends. It can be fine and it can be bad. The good news here is we don't have to make this decision forever right now. This is a decision we can revise later as we work more on developing the design. So don't get too hung up in the details and really think that, later on we can go back and fix it if we decide that isn't a good decision. So the next thing we need to do is to design the donor class. Now here we're moving from designing the classes to designing the data in the classes. Remember that I prefer to design the data first and then put the methods in later. So we need a name, we need an address, and we need a list of donations. Now, we might want to think for a minute if address should be a separate class. Well, I think it should. Addresses are very reusable. What's more, there's a lot of error checking you can do in them. Not that we're going to do that today. So, for example, you can check and see if an address has a state and a city that matches the zip code. That will prevent some typos on the zip code from sending your mail to odd places and costing you a bunch of money to get back the correct addresses. And so that's a good thing to consider. Even though we're not putting the error checking in now, by separating address into a separate class, we make it possible to do that later. In fact, we might leave it listed as a to-do in the software so people know that that's something that we think would be a great idea to add on, even if we don't have time to do it today. To go back to the design of the donor class, you'll notice that we have the name, the address, and the donations as an array list of donations. This is what the relationship looks like. Because we have an array list of donations, the donor class aggregates donations. And because we're using an address field, just a single field, address is aggregated by donor. So notice the donor class is kept quite simple this way. The donor class is kept smaller, but we have more classes. That's usually a good design decision. Now we need to design the donation class. Each donation can contain cash and several items. So this means our donation class is going to have money, which will be a double, and then items. Now notice I've made this an array list of donated items. The reason I did that is we've got some pairings going on with the donated items. They have a name and they have a monetary value. So in order to collect those two things together into a single unit, I needed to create another class. So like I say, items have a cost and a value, and so that creates the separated class donated item. Now you can see the donated item is aggregated by donation. So the relationship between classes is shown this way in UML with the open diamond. Now it's time to reconsider that relationship that we put in earlier that we weren't too sure about. We know that donor has a donation, and that donation has a donated item, and that charity has a donor. So the figure on the right shows those relationships expressed in UML. We know that the charity needs to track donations. Now, do they need to track donations or maybe donated items? Are they just trying to keep an inventory of what's in the warehouse, for example, or what was in the warehouse? To me, that makes more sense, is rather than tracking the donation, you're tracking the donated items. That also simplifies the design a little bit. Now notice donated item is still being aggregated by two classes, but the nice thing here is the donated item is a very simple class. Remember, just two data fields. We'll probably write it in such a way that it's immutable, that it can't be changed, and that also improves things here. So there are some other dimensions to design that will come up as we get more advanced in designing. So now we have a pretty solid relationship. Notice that this is not circular. The reason I say it's not circular is because there's no class that's aggregating another class, like the link we had between donor and donation earlier that was circular. That's another sign of good design. When things get circular, updating them can be very hard. So let's examine the design of our charity class. The data would be a name for the charity, because remember, we're now writing the software for many charities, not just for one. A list of donors, a list of donated items, and of course the amount of money they've collected. So here this is summarized in UML. So we see the name of the charity, the money, the array list of donor for donors, and the array list of donated items for donated items. So this is the expression of the charity class in a little bit more detail, the same charity class that was on the previous slide. Now let's talk about the design of methods. You do need to add in necessary accessor methods. So for example, we need to be able to access the amount donated by everyone, the amount donated by one donor, The thing that's important is you need to take a minimalistic approach to accessing data fields. So weak designers tend to just put in an accessor for everything, and that's not a good idea. It makes the software more complicated than it has to be, and there's no reason for it. So wait and see how you need the accessor. So for example, with the address field, probably the only accessor we need is a toString method. So don't put every accessor in there in the world. You probably won't use them. You need to choose mutator methods even more carefully than accessors, because mutators can change data. And when you change data is when mistakes get made that can't easily be fixed. So for example, we're going to need to be able to add donors and to make donations. So you're going to need to add Java idioms like toString. Now most classes should have a toString method. There aren't a lot of other Java idioms that make sense in this code, so that's the main one to watch out for. Let's talk a little bit about the design of a driver class. There are lots of possible options here. Now I'm going to choose a different option than what I did in the last program, just to give you some variety and to let you see a different style. In this case, our charity object is going to be created as instance data in our driver class. Now, because our driver class has instance data, that means we have to construct and use a driver object. Now, this is something some people find confusing, and if you do, then just create another class that drives your driver. This class is going to contain the user interface to the program. It's going to be menu-driven, so the class is mostly going to be system out, print line, and scanner work. It's actually not a very interesting class in general, other than the main program, so that's the part we'll develop later. Now the charity class really does most of the heavy lifting here. The driver is just the interface. When you're writing code, you really want to separate the user interface from the rest of the code to the greatest degree that it's possible. User interfaces are often not reusable and have to be re-implemented from scratch, and so when you know that's a possibility, you want to encapsulate it as much as is possible. Now, because we're beginning programmers, that may not be perfect, and that's okay. Now, you may be wondering, why haven't I seen any uses relationships? Well, one thing we haven't done is show the uses relationships in the diagram. For example, string class is used by many classes, in fact, virtually all of them, particularly because there are toString methods available. Because it is so ubiquitous, we usually don't show it. In other words, everybody knows that virtually every class uses the string object. To put in the string class and to put an arrow from every single class to the string class makes it appear like the string class is the center of the universe in this program. It's not. It's just one more little tool that we use. And so there's a lot of judgment that's involved in what we show and don't show. So a lot of uses relationships don't actually get documented. The ones that need to be documented are the important ones. The ones where you have a big important class that's just used in another class. This program doesn't happen to have any of those, and so you're not going to see any uses relationships documented. Now let's start to implement some of the simple classes. Now the strategy I'm using here, that is starting and doing the simple classes first, and then moving to the more complicated classes, or to use our new terminology, I'm implementing the classes that are being aggregated, and then moving on later to the aggregating classes. That's a strategy I prefer because I've had a lot of success writing programs that way. Different people are comfortable doing different things, and there's no saying that this strategy is the only way to do it or the best way to do it. So for example, let's implement the donated item class. Now, the address class is very similar to this class, so I'm not actually going to implement it. It's just lots and lots of strings. So donated items is a little bit more interesting. So here we are in Eclipse. Notice I have all my classes created. Now I did these from our designs. So we've got two instance data elements here. We've got a name and we've got a price. So inside our constructor, what we want to do is to set name to item. Now we've got a little problem because we called our parameter price and we also called our instance data price. So this is not what you want to do, say price equals price. In fact, notice that Eclipse has actually flagged this with a warning. So although it's legal code, it's not a good idea. Now there are a couple of different ways we could fix it. We could change the name of our parameter, for example. And that fixes it. Watch out for that mistake, because that can be a very hard one to debug if you decide to ignore that little yellow warning sign that Eclipse is giving us. When we get the item name, all we have to return is name. So notice this is an accessor. Accessors usually start with get. Very simple to access this item. When we get the item price, all we return is price. In general, there isn't a lot of error checking that occurs in accessors because we're supposed to do our error checking before we put the data in the program, not when we're accessing it. Now, the other thing we're going to want to do is create a toString. So a toString method is usually going to try to summarize all the data in some way that you can see it, particularly for debugging. So in this case, what we're going to do is say item name, colon, plus name, plus item price, colon, plus price. And we can return that. Now, if having those pluses in the return statement bothers you, you could create a new string object and set the string object to that value and then return that string object. That's fine too. As always, there are lots of ways to do it. So notice that the implementation of the donated items class was almost trivial. Now I put in the Java doc and the method headers and things like that for you, which did make it shorter, I will admit, but it really isn't conceptually very hard. The next thing we want to do is to implement the donor class. Now here we're going to look at the constructor, get value of all donations, and add donation, because those are the most interesting methods. So here we are in the donor class. Now the donor has a name and an address and a list of donations. So this is the instance data for the donor class. Let's take a look at our constructor first. The purpose of constructors is to make sure that every single item in this class, every single instance data, is ready to go. We could say name equals name. Now we made that mistake just a minute ago, and notice we're getting our little eclipse warning. This time I'm going to use a different strategy for fixing it. I'm going to say this.name equals name. When you say this.name, you're telling Java that you want to use the instance data that's part of this class, that version of name. And so that resolves the problem. Now some people like this and some people don't, and I don't care if you like it or not, you can do it either way. Remember, the other fix would have been to change the parameter name to something different that didn't match the instance data. And we can say this.address equals address. Now, this is where a lot of people would stop with that constructor, and that wouldn't be correct, because although name and address are now correctly initialized, donations is not. So we need to construct the list of donations too. Now it's going to be empty, but you still want to construct it here. So later on when we go to add donations, we have a place to add it and we don't get a null pointer exception. So this is the trick to writing constructors correctly, is to methodically go through every single piece of instance data one at a time and make sure that that data got initialized. If you do that, you'll have no trouble with constructors. So we see we've got a couple of simple accessors here. So get name will return name, and get address will return address. As always, accessors are extremely easy to write. Now here is get value of all donations. That's going to be a little bit more challenging to write. Let me remove our little stub here. So what we need to do is to step through all donations made by this person and add up both the money and the cost of the donated items. So there we have a strategy. We now recognize that this could be a for each loop because we're going to be stepping through our donations but not changing them. So for donation D : donations. By the way, if for each loops make you uncomfortable, you could use a different kind of loop. You could use a regular for loop. You could use a while loop even if you wanted to. There's always more than one way to do these things. So since we're going to be returning the cost, which I'm going to put in at the bottom right at the start, just to keep Eclipse happy, setting up a variable at the start is a good way to do this. So now we've got our first donation, D. So we will have cost equals cost plus D dot get, and we need to go to our donation class and look and see what the name of our method is. So let's choose get money first. So this returns the amount of money that's donated by that person. The next thing we need to do is to get our next donated item. Now in this case, when we look at get donated items over here, we can see that that's going to return an array list too. So we'll have array list of donated item list equals d dot get donated items. Now we need to step through those donated items one at a time and add up the value of each. So we'll have another for loop. So this will be donated item. I'm just going to call that I, colon, list. So we'll have cost equals cost plus I dot get item price. Now, if you don't remember the name for methods like that, remember you can always look them up by going over here in Eclipse, and it will show you what the name of all your methods are. That can be very handy as we move along. So now for every donation, we've added in the amount of money, and we've added in the price of all the donations. So when we get to the end, we return the cost. Nested for loop, by the way. Now, adding a donation for this donor, that's actually pretty easy. Because our donations are kept in an array list, we can use the array list methods to handle it. So we're going to have donations dot add D. And that's really all there is to it. So that adds another individual donation to our list of donations for this person. Now, as we go along, we should be testing these classes. In order to keep these videos a reasonable length, I sometimes short-circuit that, but I really don't recommend it for you. Now is the perfect time to find errors in these classes. You really don't want to be waiting for the end. So the next class we should implement is our charity class. So we're going to implement the constructor, because constructors tend to cause people problems. We're going to implement make donation, find value of all donations, and find value of one donor. And we're even going to find another little method that we're going to need to create called find donor. Now that's going to be a private method. The reason it's private is because notice we didn't identify it when we were creating the design, but we are going to find it useful. So anytime you're writing code in a class and you think, wow, I think I've written this code before, that's a hint that there may be a private method that you could make and reuse. So here's our charity class. I see that I forgot to remove my details for the constructor, so I guess we'll just look those over instead of rewriting them. So the constructor for the charity class only gave it the name. The list of donors, the list of donated items, and the money donated, all of those get initialized separately. So there's nothing to construct from those, because when a charity starts out, it doesn't have any donors, it doesn't have any donated items, and it doesn't have any money. So that's a good thing to do. Here's the little private method I was talking about, and that's locating a donor that's already in the system. Now, if you think about it, it's just a for loop, so we've stepped through all the possible donors, and if their name equals the name that we're looking for, we return that donor. If we get to the end and we haven't found them, we return null. So that's a very routine method, the kind of method we've written many, many times. I see I have it public here, and that is not correct. It should have been a private method because we're only using it within this class. This isn't something somebody needs to be able to do outside of the class. And so since they don't need it, we keep it encapsulated. Now later on we may find we need it outside of the class, and if we do, we make it public then. This is part of our strategy of implementing code conservatively, doing it as simply as possible, not adding complications if we don't need them. Let's look at making a donation. So we've got a name for a donor, and then we've got a donation. Well, the first thing we need to do is find that donor object. And that's where our find donations method comes in. So that's kind of nice. Notice it can do the work for us. Now we'll do donor.add donation. Donation. That's the method we wrote just a few minutes ago in the donation class. So notice the work here again, very simple, very straightforward. This is what comes from good design, is short, simple methods. Now if you're thinking, well, isn't 2 lines too short for a method? No, not at all. In fact, it's perfect this way. Short methods, good methods. Now let's find the value of one donor's donations. Now the reason I'm doing that before find value of all donations is that we're going to call this method in find value of all donations. Now unlike our find donor method, this time, we actually do want to have this method be public. Because remember, this is one of the things we're supposed to be doing in the interface to the program. So we know the driver method is going to need to call this. So the first thing we do is donor, find donor from the name. So once again, we're reusing that find donor method. Now, if you hadn't thought to write that at the start, when you were writing this code, you would have found that you were rewriting the code you had just written above in make donation. That sense of deja vu, I've written this code before, that's what tells you you need a private method. So learn to listen to your instincts about that. In our donor class, whose design we might look at right now, notice that we have a method called getValueOfAllDonations. That is what we want to return. So don't go and redo work you don't have to do. So donor.getValueOfAllDonations. I suspect right now you're realizing why I leave the Package Explorer up on the left-hand side of my window so that I can access these things quickly and remember what all the methods are. Keeps you from redoing a lot of work the hard way. Okay. So now we need to find the value of all donations. Well, that boils down to stepping through the loop and adding up the donations from every donor. So here we go. I'm going to use a for each loop again because we know we're stepping through all of the donors. Because we're returning a double, we know we're probably going to need one of those. And of course, we'll initialize it to 0 as always. And we'll do D dot, Well, we could get value of all donations for the donor. That would be one way to do it. And remember, we want to add that to money. And of course, at the end, we're going to return money. So that's a simple way to do it. Now, a mistake that could very easily be made here is to add the money that the charity has in at this point. But that would be wrong because remember, all that money was coming from the donors. So it's already been added in. These are the kind of things that you'll notice when you test. And so notice, even though I'm not testing and setting a very bad example here, this is definitely a place where testing could save you an awful lot of grief. So once again, notice very short methods in this class. Nothing's getting long and complicated. That happens because we've designed things well. Now, here's the next thing, and that's to implement the driver. This is something that causes people a lot of trouble, particularly the main method here. So that's the one that I'm going to implement. The thing that gets hard is that inside the method we need to construct an object from the driver class. It seems like that's circular, but it really isn't. The reason we need to construct the object is because we made charity instance data. Now, there are lots of different ways we could have worked around this. This is only one possible design, although it is a good design because it allows multiple charities to be created. And remember, our goal here was to make this software for a lot of different charities, not just one. There's a loop in the main method that basically prints out the method and implements the choices. So let's go and write that. Here's our driver class. Notice we've got instance data here for our charity object, and then I've got a decimal format. That's just for formatting some numbers as they're coming out. I made that static because it's going to be the same for every object, so there's no reason to create a different one every time. We can have one for the class and share it amongst all the objects. Then I created a bunch of constants for the various things that we're going to need to do. This is a nice way to implement a menu-based system. Here is our driver class. We've got to be careful to make sure we implement the correct things. This is our driver constructor here. We have only one instance data object, and it's a charity, and so we need to construct that object. I don't know what that little comment is doing there. Clearly I left some garbage hanging around, so let's clear that out. So we've done our job in the constructor of creating the object. Here's the main program. The thing we need to do here is to construct a driver object. So I'm going to give this charity a name, one of my favorite charities, because it's where I adopted 2 of my 3 dogs from. So there we go. Our charity now has a name, and we have this object to use. Now, this is just a menu-based system we have here. So the first thing we need to do, I'm going to move this up so you can see the methods that are available in the driver class in case you've forgotten them, is we need to get our menu and response. And that needs to call a scanner object, so we need to construct that. Of course, we would also need to import the scanner class, but I've already done that. So there we go. We now have our choice from the menu system. Let me show you what that method looks like just so that you have a chance to see it. Here it is. What it does is it prints out the menu first, then it asks the user to make a choice. It reads in that next line, and the reason you're doing that is to get rid of the new line after the integer so it doesn't mess up your future input. And then you force the user to re-enter a choice until they have something that's legal. This is a very typical pattern for a menu-driven system. Okay, we have this choice is not equal to quit. And by the way, because we want to quit and not do anything else, that's why I did the priming read here. So if the choice is add donor, well, what are we going to do? Well, we've got a method called add donor that's in this class. Notice that it is an instance method. And so we need to make sure that we call it from the instance. Now our instance was called pets and people dot add donor, and it needs our scanner. And that's all we have to do here. The actual work of the add donor method, the entering the name, the entering the address, and creating the objects, all that is done in the method. Now, where people seem to have trouble with this is remembering to put the pets and people object in front of it. So this is an object of class driver, and that's the donor that we're adding. Now, to add a donation, we're going to use the add donation method. So once again, inside that method, what we have are a bunch of input and output lines. We construct some new objects, and then we call methods that are in the charity class. We'll look at one of these at the end. Find charity value. When you look at that, you realize, now wait a minute, we don't have a method for that down in the driver class. There's nothing here for that. So we might take a look up at our charity class and see if there's something in our charity class that we could use. And notice in the charity class, we have something called Find Value All Donations. Well, great. Here we're going to do pets and people. Now this is in the charity class. So we need our charity object. And then we call Find Value All Donations, a method we wrote just a few minutes ago. Now, because this is our final output here, we want to put some data in here. Now, if we do it like this, our output will be ugly. And the reason is because Find Value of All Donations is returning a double. And remember that we'll get odd things. We won't get those nice 2 decimal places that we're looking for. This is where that static data for decimal format came in. So we have this dollar format, and that's what we want to use to format this data. Now notice I did not have to say the class name in front of it because we're in the same class, and it's not instance data. If you had put pets and people.dollar format in front of it, that's technically okay. It wouldn't confuse Java, but it's not the best way to write it. So this is a nice way to write that data. Now for find donor value, if we scroll where we can see our driver class, we can see we do have a method called find donor value. So we'll do pets and people. And of course, like all these methods, it needs to have the scanner so that it can interact with the user. This last else is a precautionary measure. So what we want to do in here is to put a system out print line, unanticipated case. The reason you do that is that sometimes you'll go and you'll add more methods and more choices to the menu in later. In fact, there are a lot of choices our menu really needs right now that it doesn't have. And if you forget to update this method, nothing will work. So this way, at least you'll get a useful error message that will help you find what the problem is. Now, the other thing we need to do at the end of our while loop is to get another choice from our menu system. So that will be menu and response of input. Easy to forget that. And let's put that this is a priming read. So these little driver class main programs seem to cause students a lot of trouble. Now, there are lots of other ways we could have implemented the driver class if you found what I just did confusing. One is we could have put the driver object in another class. Sometimes that doesn't confuse people so much because it's more similar to what we've done in the past. We also could have made the charity object class data instead of instance data. Now, I got to tell you, I don't like that choice as well because we were trying to implement a class that could be used by many charities. And when you make it class data, well, then there can only be one. And so I don't think that's as good a choice. On the other hand, if it's what helps you get a program together, maybe that's an option you want to take. So let's talk a little bit about what good design is. If you noticed when we were implementing these methods, it was really quite simple. None of our methods was more than a few lines long, and that's really good. By the way, there is an exception to that. When you look over the driver class more carefully, you will see that some of those methods are longer than the other methods. The reason is because you're interacting with the user. And that where you have to read in data and convert it and all that, that tends to get lengthy. And that's okay. We know that code isn't highly reusable because that's probably going to be the interface for just one charity. But nonetheless, small independent classes is what we're looking for. Now, you're more likely to be able to reuse small classes. So for example, when we pried the address class away from the donor class, We created a smaller class that could be reused for a lot of things. For example, charities purchase things. So vendors are going to have addresses. Staff are going to have addresses. Volunteers are going to have addresses. And as long as you make that class independent, you can reuse it a lot. So this is where you start to see how you can make your life as a software engineer a lot easier. The other thing that's good about small classes is they tend to be more simple and they're more likely to work as expected. We haven't really done anything more complicated in any of these classes than stepping through an array list, something that we've been doing for a month or more now. And it's something that's very simple. So things that are simple are less likely to go wrong. So while software itself is complicated, the art of design is trying to keep things as simple as possible. The other thing we want to have is a small number of relationships between classes. In our current design, our donated item class is related to 2 classes, which is not too bad. What you don't want to see is things related to every class. So we might think about whether we could remove one of these links. And actually we could. We could remove the link between the charity class and the donated items class and just get our donated items from the donors directly. Should we do it? That's actually a really hard question. And because our software is still pretty incomplete, it's hard to know. My sense is that we're going to want to know what the donated items are just to keep track of what's in the warehouse. So my guess is that probably we want to leave it there. But of course, the conservative approach is always to not have the relationship there and put it in later if we need it. So it's something to think about. So let's take a look at 2 typical designs. And let me explain what makes one of these designs better than the other. The design on the left is generally a bad design. You have a small number of classes, which could be okay if the problem is small. But the problem here is that every class has some relationship to every other class. When you have things that are tightly integrated like that, it means mistakes you make in one class are going to tend to mess things up in another class. And those are really hard to debug, because when you find an error in class A, it's hard to remember that it may have happened in class B. Take a look at the design on the right, which is generally a better design. There are more classes, and you might think, well, gee, that seems like a lot of classes. But it's not the number of classes that makes things complicated. It's the complexity of the relationship and the complexity of the classes. So as long as these classes are simple, notice they have very simple relationships between them. So in general, the design that you're seeing on the right would be a better design than the one on your left. And you need to identify that when you're doing designs. The challenges that remain. One challenge is keeping the design and the code aligned. Now, we could have done an omelette diagram like we did in the Greyhound adoption. It's very easy to forget to update the design when you do this. There are software products that ease this process. What they do is they update the design when the code is changed. These are really cool things to have. Some of them can also create some of the code when the design is changed. So they'll do things like implement new methods by putting the signature in for you. That can be kind of useful, but it also can be kind of annoying. The only problem with these products is they tend to be quite expensive. Now, as more and more software becomes available for free, there may be some good things out there. I know the first time I used this in a company that I owned, we actually had to pay $10,000 a copy for software that did that. And frankly, we did, because it was worth it to keep the designs and the code the same. When you have multiple people working on it, it's really important that everybody knows what's going on. And keeping the design correct was very important. I was afraid my software engineers wouldn't do that, wouldn't remember to make those updates, and that's why I paid all that money. Oh yeah, by the way, that was a yearly license fee, not a permanent one. So you can see that I think the design is really important. So let's make some observations about where we're going with programming now. You'll probably notice there's a shift in time allocation happening. Design becomes the main activity, with UML being the critical part. Good designs lead to fast and simple implementation and a lot less debugging. So the time you spend on design should save you time on implementation. Now, obviously, it takes some time to get to the point where that's really true. Now, the mistakes I see students make in this case, one is rushing to implementation, often sometimes without even doing a design at all. You get so focused on having to get that problem done and get it submitted and get it in that you forget that a good design is actually going to save you a lot of time. The big mistake I see is doing the implementation first and then doing the design after the fact. And that is a habit you have to get out of if you're going to be a professional in this field. Because the design, once you've implemented it, you're going to be very reluctant to change it, even if it's horrendously wrong and causing you a lot of grief. So do not get into the habit of implementing first and designing after the fact, or more accurately, taking your implementation and writing it in UML after the fact. That is a horrible habit and one you should not learn. So keep programming.